So our next speaker, Todd Vision, who's on the faculty at the University of North Carolina, Chapel Hill, and also one of the founders of, is it Dryad or Data Dryad, your official name?
Either one works.
Either one, okay. Which is one of the older open repositories for a deposit of research data that's still in existence.
Thank you. Afternoon. Can everyone hear me all right? Yeah, sounds like the mic's on. Good. So, I want to talk today about making research data integral to publications, so following on many of the themes we've already heard. So in order to make research data integral to publications, we need to contend with the problem of not big data necessarily, but small data, which in aggregate is big data. There's quite a lot of research data that's out there that is not being captured by the research communication, dissemination process now, and it's highly variable, so it also meets that criterion of big data, extremely heterogeneous. This is just a classic example I like to show of a table. There's about 15 pages of this, I think, that were published in a 1898 article that's highly used in my field. I'm an evolutionary biologist, and this is used in all textbooks and so on, because all the raw data is available. It's one of the first examples of natural selection happening in the wild. But so it's a spreadsheet basically of quantitative data that's very idiosyncratic. No one ever collected exactly these variables in this form ever before or since. And the long tail of what's sometimes called artisanal data is full of this. Every field has it. It's not a biology thing or a physics thing. It's from archaeology through zoology, right? So A to Z. The intellectual complexity and information content of these data is often very high, even though it's very idiosyncratic. You won't see the same spreadsheet again, but that spreadsheet is going to contain the data that underlies the statistical analysis, the points that are plotted in the figures, the summary data that's reported in the table. And if someone wanted to actually reuse the research data underlying the paper, often they need access to this processed data, which isn't the raw big data on which the research started necessarily, but is what's immediately behind the publication. So that's the kind of data I'm going to talk about, and that's where I think the biggest crisis and the biggest need is that intersects with what publishers can do, is to work with these kinds of data. So a very interesting study that came out last year looking at the consequences of the traditional method by which these data were shared among scientists, which is sort of peer-to-peer dissemination. Many journals obviously have a policy where you can ask for the data and authors are expected to send it to you by email, but that is predicated on the idea that they actually still have the data in a form that's shareable, and that is very difficult. So the study, focusing on one particular type of small data, sort of statistical analysis in biology, looked at several hundred data sets, saw attrition over the years, partly due to loss of contact. It wasn't possible to email the authors anymore. They'd moved on. If they did email them, they didn't respond, or if they did respond, they couldn't find quite the right data, or they did send something, but it wasn't the right thing. So there's attrition at many stages, and this is just one of the more rigorous studies to show that sort of peer-to-peer dissemination is very ineffective, and I think they found overall about 17% attrition every year from publication of the ability to collect the data afterward. So pretty serious after 20 years. You don't need to read all the figures on this, but if you're not aware of this publication, it's actually it's a good resource. So this may contradict a bit of what Carol told us earlier, but my take on this actually is the attitudes of scientists towards sharing their data are actually rather positive as opposed to the practice of it. And as a result, I don't think there's actually a need for journal policies to sort of pussyfoot around the issue of making data more routinely available. So this survey of scientists from lots of different fields, so social sciences and atmospheric sciences and medicine, 70 to 90% of scientists agree somewhat or strongly that they're willing to share data with researchers outside their field. More than 4/5 want, in return for that data, to be cited when it's used, which is what we generally agree is as a good norm. And more than 2/3 think it's appropriate for others to make derived data sets out of those. So those numbers actually vary surprisingly little among the disciplines, and it's overall fairly encouraging that the attitudes of scientists are fairly positive toward data sharing if they get the prompts and the technical infrastructure and the rest of the social engineering is right for them to do it. So in my own field of ecology and evolutionary biology, a group of learned societies and journals rolled out a discipline-wide policy in 2011 that was negotiated among all the parties. It's since become so ingrained in the culture that colleagues of mine will get shamed on social media if they neglect to release their data for a high-profile study. It routinely happens. The debate has moved on to whether the embargo period that was negotiated for this, so one aspect of this negotiated policy was that some journals allowed authors to embargo the data release until a year after publication. And this is where a lot of the discussion is now, is over whether that's the right time period or whether that should be allowable at all. And many journals that have adopted policies like this since have done away with the embargo. They don't allow it at all. Feel it's unethical. So arguing that this is unethical and shouldn't exist at all would have been unthinkable 4 years ago. The conversation has moved on and attitudes have changed as a result of this policy being adopted by many journals in the field. So again, 4 or 5 years ago when this policy first came around, there wasn't infrastructure to support such a policy. It wasn't clear where an author would deposit data underlying their article. Publishers weren't terribly excited about greatly expanding their supplemental materials infrastructure to support it. And that's, in fact, why Dryad, which I'll talk about in a bit, was founded. But now there's a host of different solutions that handle long-tail data of various kinds, from social sciences, based at CERN, Dryad, I'll talk about, Figshare, you're probably familiar with, Open ICPSR, a relatively young entrant for social science, Pangea we've heard about, GigaDB, which can handle extremely large data sets in biology. These are just some of the well-known offerings out there that are of general use. This registry, re3data.org, recently announced that there were 1,000 data repositories in its registry. It's all it does is it registers data repositories worldwide, institutional, disciplinary, of all different kinds. Some of them are available for many people to use. Some are only provided as a service for niche audiences. But there's a huge diversity of repositories out there now that can take various kinds of data in different disciplines, in different countries, different funding organizations, and so on. So scientists love to worry about sort of the edge cases, and one hears all the time, I'm a special snowflake, my data are too large for a repository, but GigaDB can handle that if you're in the biosciences, or I have sensitive data, human record data. And there are services arising, thing called Yoda at Yale, for dealing with enclave access to qualified researchers rather than simply making data openly available. So there's repositories that are rising to fill these niches all the time, and the edge cases are falling away. But if you ignore the edge cases, there's still an enormous volume of just long-tail data underlying the literature that's not being made available despite all these repositories. That's data like Bumpus's sparrows. It's plenty of work still to be done just to make the use of these repositories routine for data that have no particular technical or legal or ethical concerns about being openly shared. So the metaphor I want to use is that of a bridge. So as organizations in publishing, this community is asked where authors should publish data and how they should publish data with a lowercase p kind of publishing. And I think you need to be thinking to yourself, I need a map of this complex landscape. I need to understand which ones are relevant for the community that I serve. So to wax a little metaphorical for a moment, the most important features on this landscape are the bridges. There's bridges of various kinds. There's bridges that span between the technological worlds of research data, we heard a lot about in Simon's talk, and that of publishing. There's bridges that span between making the data available, business models that make the data available for free, and those that actually sustain repositories for the long term so that the preservation for future availability is ensured. And those repositories that span the culture of academic scientists who have all sorts of norms and professional expectations and obligations associated with publishing articles, but when you talk about other kinds of research objects, like software, like data, they somehow don't bring those along. Is that a matter of incentive or legacy or the systems or what is causing that disconnect between them? So we need to bridge those cultural gaps. So what sets Dryad apart to some extent is its focus on this kind of low-hanging fruit of data that's associated with the peer-reviewed literature very closely. That's across all of sciences and medicine, although largely the content is from the biosciences. But any country and any reputable publication that has data is eligible for hosting, as long as there's no issue releasing those data into the public domain, so no sensitive data as well. But that's still a huge slice of the pie. There's millions of articles with data of that kind published every year, and only a small fraction of them, the data is actually made available currently. So Dryad was launched in 2009. It's currently publishing data for about 200 to 250 articles every month, plus a few books and theses. And these are associated currently overall with data from over 350 journals, so fairly diverse already. And a key ingredient in this growth is submission integration. So we heard earlier about linking between articles and data kind of post-publication. And what we're talking about here is trying to make the submission of data to the repository actually part of the pre-publication process. So using lightweight messaging behind the scenes, metadata for the articles passed between the journal and Dryad at various stages in the submission workflow so that the author doesn't need to actually enter metadata that the publisher already knows about. I like to say that every time an author is asked to enter the same metadata twice in the same or different systems, that somewhere in the world a puppy dies. You know, it's kind of, although there's 350 some journals with data in Dryad, only 60 journals actually integrate data at submission. We're trying to increase that number, obviously. But those are responsible for 3/4 of the submissions to Dryad. So this route where the journal actually provides the link to Dryad either before review or after acceptance is what drives authors to actually take advantage of the service most of the time. But the integration process is very customizable to different journals, so data can be made privately available to reviewers, or authors can only be asked to upload data after the review is done. We can turn on the ability for a journal to allow embargoes for its authors or not. So it's really just supporting the variety of journal policies there are for data. It's not necessary that a journal requires data deposit in order to take advantage of the service, but even just integrating submission alone incentivizes those who would be inclined to take advantage of it, even if it's not required of them. So great diversity of journals using different kinds of submission systems are able to take advantage of it. We just last month integrated PLOS One, the largest journal in the world, so pleased about that. So this is an example of a data package once it goes through submission integration. And you see down here the citation for the article at first. So we always have good bibliographic information on what article the data is linked to. And what's interesting about the citation for the data, which looks very much like the article, in this case, the authors, the order of them is somewhat different. There's a different first author on this than for the article. So someone's taking credit for the work that they did on the compilation of the data that they wouldn't that they wouldn't otherwise get for just the article. We also, you can see, track the downloads of the data packages. This is just one Excel file that's been downloaded more than 7,000 times. On average, I think we're getting something like 15,000 data downloads, file downloads a month across all the content in the repository. So the stuff is being used. I'll talk about citation tracking in a minute. But these download numbers are things that can be given to, sorry, Cassidy, altmetric providers like Impact Story, Plum Analytics, and so on. So although still rare, we do see some instances of data being cited in the literature. There was recently a publication from Strasser and Lin in PLOS about recommendations, I don't have the reference here, recommendations for publishers to encourage research data availability. One of the main things is that we're seeing, even with journals that are integrated with us and have policies that are pro data archiving and data citation, the copy editors don't always get the memo, and when authors do attempt to cite data in the bibliography, as is kind of recommended by Crossref and DataCite, that it comes back to them as an error and it's stripped out. And that's really pervasive. So that's actually a very small thing that publishers can do that would make a big difference. So when it is available in the citations, obviously it's easy for groups like Data Citation Index to pick it up without having to scan the full text, which is obviously more error prone. So here's an example of a Dryad package that's in the Data Citation Index. Because data appearing in the bibliography is so rare now, currently there's really not much accurate. It's not accurately tracking reuse. We see a lot of reuse for downloads, and we know anecdotally of reuse being used for research that we're not seeing showing up in indexers' data.
2 minutes.
2 minutes? Okay, thanks. We're seeing authors promote it in their CVs as a separate object that kind of adds value to their research. Thanks to the EU-funded Odin project, we're seeing the assignment of DOIs to data also allowing them to be pulled into ORCID profiles. This is an example actually of my own paper. So here's the paper, here's the data, both in my ORCID profile. And authors are promoting this to their peers as they're building their reputation on the availability of their data and the quality of their data, and this is something that they're proud of. So this actually, I think, is one of the more valuable uses of altmetrics, is being able to promote your flavor of impact as you see it as a researcher. We saw examples from Elsevier of linking out from a online system to data in a repository. Sorry for the blurry image. This is an example for Taylor and Francis. There's no bilateral arrangement with Dryad in order to provide this link to the data from their system. They use the fact that DataCite is aware of the link between the article and the data, which is a nice thing that just happened unexpectedly. They never contacted us about it. And here's an example for Elsevier. So the last point I want to make is just about bridging business models. Dryad was one of the first to introduce data publishing charges, which are responsible for most of the revenue for the operation. They're a little over a year old. It's also a nonprofit membership organization, and members get slight discounts on the data in, but it's basically a one-time charge that covers preservation and curation and so on. And it's relatively modest compared to article charges, and it's gotten fairly good uptake. But I know this is of interest to some of you. I don't want to talk about specific price points, but I think the general model is being used by other data repositories, or at least being considered by many other data repositories. And I think I'll stop there. Thanks.
Okay, thank you very much.